Today we're talking about prime factorization, and if we're trying to express a number as the product of its prime factors, we're not looking for all of the factors in the numbers. We're just trying to get that number down to its prime factors so that when I multiply those, I get the number I started with. So I can find out what non-composite numbers make up a number like 24. Now there's a number of ways to do these. I'm going to start with 24, and one way to do it is the factor tree, which is where you take a number like 24, and I split it into its multiplication, whatever I think of, two numbers that would make that up. Let's say 8 times 3 would make that up. Now I know that 3 is prime, but 8 is not, so I can look what makes up 8 is 2 and 4. Now I know that that 2 is prime, but 4 is not, and I know that 2 times 2 make up that 4. So when I look at the end at all my circled numbers, I know that a 2 and a 2 and a 2 and a 3 make up 24. And if I multiply them, 2 times 2 is 4, times 2 is 8, times 3 is 24. I could also rewrite this as 2 to the third times 3. Both are considered the product of the prime numbers. I prefer a different method, the cake method, where I continue to divide. So if I take a number like 24 and I set it up as a division problem, I would just think of what numbers factor or divide into 24. I know 24 can be divided by 2, because that gives me 12. And I know that 12 can also be divided by 2, and that gives me 6. And I know that 6 can be divided by 2, and that gives me 3. And everything that's left, 2 times 2 times 2 times 3, will match what we came up with right here, and will give us the prime factorization of 24. If we try a number like 30, switch over to 30 here. I'm going to start with the cake method. I'm going to say that 30, I know, can be divided by 2 because it's even. So that's 15, and I know that 15 can be factored or divided by 3, and that gives me 5. And I can't do anything with 5 because it's already prime, so I've got 2 times 3 times 5. So its prime factorization is 2 times 3 times 5. I could also use the factor tree, which is splitting 30 into, let's say, 3 times 10. 3 is prime, and I can split 10 into 2 times 5. They're both prime, and I still get the same answer that I started with here. Why don't you take a second and try 60? You can pause the video, and then we'll go over what the prime factorization of 60 is. Okay, so let's try 60. I'm going to use the cake method. It's my preferred method. So if I take 60, and I think what factors it, or what can divide into it? It's even, so I'll try 2. That leaves me with 30. That's even, so I'll try 2. That's 15. That's not even, but the next prime number is 3. That divides into 5, and then I can't do anything with 5, so what I'm left with is 2, 2, 3, and 5. So I know the answer is 2 times 2 times 3 times 5, or 2 to the second power, 2 squared, times 3 times 5. They're both considered correct. If you used cake method, you might have split it into, let's say, 6 and 10, neither of which are prime. 2 and 3, both prime. 2 and 5, also both prime. And I still have 2 times 2 times 3 times 5, which exactly matches what we came up with the first time.